Hello and welcome to What is a Color Sensor? In this activity, we're going to talk about what a color sensor is and how it's used, and then you're going to collect some real-time data on light reflectivity, and you're going to use that data to turn your code node into a color detection sensor. This is going to be an awesome activity. So let's talk first, what is a color sensor? A color sensor is a type of photoelectric sensor which emits light from a transmitter and then detects the light reflected back from the object with a receiver. You may have learned about this type of light behavior in your science class. So essentially, what do you think happens if you take a flashlight and shine it into a mirror? If you said it reflects or bounces back in the direction that the mirror is at the angle, you're correct. So essentially, you're going to be investigating how color reflects, different colors reflect. So for this activity, the setup's pretty important. Now, I'm using a rod and clamps to hold my code node and my flashlight, and I have them set at probably about approximately 20 centimeters above the table. Now, if you don't have this, just get a partner, and just be sure that the partner is holding the code node and the flashlight at the same height through your entire data collection. Sometimes it helps to be near a wall, so you can kind of use that as a gauge for your height. So just remember that, very important. Keep the height the same for the code node and the flashlight through your entire data collection. All right, so light reflectivity is what we're going to dig into first. You have in your kit, or you need to collect your code node, an LED flashlight, and then various color blocks. If you want to use additional ones, that's perfectly fine. It's just really important that you have at least black and white, maybe a blue, a red, a yellow, and then also foil. Now, I wrapped my foil around a piece of cardstock just to make it a little bit more easy to work with. All right, so what you're about to do is pause the video and go into SparkView software, and you are going to create a graph of brightness over time. And then step by step, you are going to place, starting with your white piece of paper, you're going to place that on the table, just like so. Start collecting data, and every few seconds, place another piece of your paper down, and you're going to collect different color reflectivity data for each of these colors. All right, go ahead and pause the video and be that data collector. All right, everybody, welcome back. I'm sure you saw the data you collected, which was pretty awesome. Hopefully you followed the instructions in your student activity sheet, because after you collected that data, you needed to use the tools in SparkView to mark the coordinate of each data point, so you knew the percentage of light reflectivity for each color, and then use the text tool to mark what that color is so you can refer to it really easily. All right, so let's do data collection together. And you might notice that my numbers might look different from yours. Again, I'm in the video room here. I've got a lot of bright lights on me. You might have fluorescent lights in your classroom. Maybe you're even at home and your room's not as bright. So don't worry if my data doesn't look just like yours. Okay, I have my white piece of paper down, my code node connected, and my flashlight on. Let's start collecting data. Okay, excellent. Very interesting. Orange. I'm curious, what's black gonna do? All right, green. And the foil. Excellent, so I have data collection of all of my color blocks here. I'm going to stop collecting data. You can use this tool here to scale to fit your graph. All right, so what I had asked you to do before was to mark the percentage of color reflectivity. with your light sensor and the color in your graph. And I'm going to show you real quick how to do that if you might need some help. All right, so the first color I used was white. I'm going to click on that line, click the coordinates tool, and I see that that's registering at 7.5% brightness. I'm going to click it again, and I'll get this text tool, and I can type in white. All right. I'm not going to do that for all of those. I just wanted you to see at least one of them. And I'm going to bring you back, and you might be able to see a sample of mine here where everything is marked and labeled. And from here, you are going to turn your code node into a color detection sensor using that real-time data you just collected. Here's your challenge. You must be able to identify 3 different colors based on their light reflectivity data. You're going to need to create a baseline for when there's no paper on the table here. You're going to create a text output that alerts you to what the name of that color is of the 3 that you decide. And then you're going to either save or export your program according to your teacher's directions. And I want you to share it with other people so you can see how people might have done it a little bit differently from you. All right, so you have your marching orders. I know you can do this. You're going to pause the video now, refer back to your student activity sheet if you need to for directions, and create your color detection sensor. Hello and welcome back, my computer programmers. I hope you were successful. I'm sure you were. All right, so I'm going to mimic a program that I created. You can see it is pretty complex because you have to put comparison blocks in when you're referring to your light reflectivity data to give you those parameters or ranges for each color. When you do this activity, it's important to pay attention to those numbers because some of these colors might be so close that it's tough to detect between the two. But that's part of this process, guys. You are going to be computer science engineers, which means your programs aren't always going to work the first time around. So you get a chance to kind of debug and tweak to get it to work for you. So the 3 colors I chose were blue, yellow, and white. And then I have my baseline set. Remember to pay attention. My top here, my table is black. Your classroom might be different. That will adjust your baseline percentages, but you'll look at your real-time data and figure that out on your own. All right, so here's my program. I'm going to switch over to a data view, and I've created a graph of brightness over time, and then I have my text output feature that's going to show up on the Blockly screen. When I hit start, if I've done this right, it should say baseline because that's where I'm starting. All right, let's give it a whirl. Start. Excellent. Baseline. Blue. And you'll notice you need to make sure that your color block is under the flashlight piece there. All right. Yellow. And white. Excellent. You might have seen my screen flash for a second on blue. Again, that's why it's really important for you to make sure that your parameters or your ranges are set right. I'm going to pull that out and it should say baseline. Let's see if it says yellow again. Excellent. Isn't that cool? You just created a color detection sensor. These are used in manufacturing, food and beverage. You'll see them in automotive factories. It's really, really cool. Think of the possibilities. You could create a candy sorter down the road with something like this. Very, very cool. All right, guys, I'm glad you joined us. Between the activities you did in collecting your real-time science data and doing your programming, you should have enough information to answer those questions. And don't forget to think back to what you've learned about light behavior too, because that all has part of this. Engineers use science to solve problems, and that's what you just did today. Thanks for joining.